Good afternoon, everyone, or good morning, based upon where you are located. Like me, I'm in US East. I'm Sherry Dean, a senior AI ML specialist solutions architect at AWS. I mainly work with our customers to help them develop and migrate machine learning workloads on AWS cloud. So today, I'm gonna share with you like how we use Flower package to implement federated learning on Amazon SageMaker. So federated learning is a machine learning approach that allows for multiple separate training sessions running in parallel across large boundaries. And these large boundaries, it can be geographic boundaries, and then aggregates the results during the training process to build a generalized model, or we call this a global model. So when we put federated learning on the cloud, the training usually occurs in multiple separate accounts or across regions. And each account or region has its own training instances. And the training data, it is always decentralized from the beginning to the end. So this characteristic of decentralized data all the time from the beginning to the end allows federated learning to solve challenges related to data privacy and scalability. In those scenarios, like we're sharing data, it's not possible. So we do have customers, especially customers from government agencies or healthcare institutes, that they want to leverage bigger data sets from other agencies, other organizations to get a more generalized model. But however, data sharing is not allowed usually in between these agencies. So in this type of scenarios, in this type of use case, federated learning is a perfect fit. When we consider like what type of federated learning framework or package that we should choose for the use case, usually we need to consider like what type of model category does it support, or what machine learning framework it supports. For example, does it support a general data size package like scikit-learn? Does it support TensorFlow, Hugging Face, or PyTorch? And does it require a specific device or operating system for the package? But when we consider to put a package in the cloud, there are some other like extra considerations. For example, the package's extensibility. Can it fit the scalability of the computing resources on the cloud? Or is the package size too heavy to install it onto the computer resources in the cloud? So based upon all these considerations, we chose Flower because it is an easily extensible, customizable, and a lightweight framework for the federated learning on the cloud. To do federated learning on the cloud, as I mentioned before, usually the training process happens across regions or in different accounts. So what we need to do, like in network setting part, first those computing process, they happen in VPCs. So here VPC, if you haven't heard this word before, VPC stands for Virtual Private Cloud. So Amazon VPC gives you full control over your virtual networking environment, including resource placement, connectivity, and security. So after we place the training resources in different VPCs, we need to do a VPC peering, this technique, to make sure these two VPC networks, they can talk to each other. So a VPC peering connection is a networking connection between two VPCs, which enables you to route traffic between these VPCs using private IPv4 or IPv6 addresses. And the instances in either VPC can communicate with each other just as if they are within the same network. So this is the networking side that we need to set up to do federated learning in the cloud. And with regard to the platform to do the implementation, we use Amazon SageMaker, our managed machine learning service that makes it easy for machine learning developers to build, train, and deploy machine learning models at scale. So Amazon SageMaker provides two types of notebooks. One's called the Studio Notebooks. These notebooks are quick start collaborative notebooks that integrated with a lot of purpose-built machine learning tools. And another type of notebook, we call it notebook instances. So these notebook instances, they are standalone, fully managed Jupyter notebook instances in the Amazon SageMaker console. So to implement federated learning, we have to use notebook instances. Basically, SageMaker notebook instance, it provides you like a familiar Jupyter notebook application through a fully managed machine learning Amazon EC2 instances. And the notebook instance, it has a variety of networking configurations available to it. In our federated learning setup, we have the notebook instance run within a private subnet of the VPC and don't have direct internet access. So here's the launch notebook instances in VPCs. Okay, after we have figured out all this background information, I'd say, then here's a full architecture of setting up federated learning on SageMaker with Flower package. So first we set up two accounts. One is the server account, the other is the client account. These are AWS accounts. And in each account, we launched a VPC, virtual private cloud. And inside the VPC, we launched a SageMaker notebook instance. So in the client, and we also did the VPC peering via the private subnet, where the SageMaker notebook instances are launched. So in the client account, the SageMaker notebook instance, basically we implement the federated learning client that trains a local model using a local data set. The local data is sitting in 3 buckets. That's the common location for SageMaker training process. We put the data in S3 bucket. And in the client account, so the federated learning client trains on local data to get a local model and send back the model parameters to the server account via the VPC peering. And then in the server account, so this is a federated learning server where that server sits. So basically in this account, the server sets the strategy for the federated learning, like the strategy for the weight aggregation, right? And it does the global evaluation using a separate like global data set, a separate data set to evaluate the global model and generate a final accuracy matrices. All right, so after that, there are a couple of like implementations that we have to do. So one is about after we set up the VPC, did the VPC peering, launch a notebook instance in each VPC. Next implementation is about we need to configure cross-account access setting. So cross-account access settings, basically it's delegate access from the server account to the client account by using IAM roles. So we created an IAM role in the client account that allows the server account to kick off the training process, to start the training process, to stop the training access. But the client account doesn't have access to the data or see the output of the training process because in the IAM role, we define the policies like what type of actions the server account actually can do. Okay, after we define this IAM role in the client account, then in the server account, we grant access to this IAM role in the server account. Then in client account, of course, we need to implement a federated learning client using Flower package. And in the server account, we implement a federated learning server, same using Flower package. Then when we start the training process, first we assume the IAM role to the server account to run the training job, to kick off the training job in the client account. And then the server account, it aggregates local models, weights into a global model, and during the process, and it do testing during the process. to get the global accuracy matrices. And I know it's kind of a rough walkthrough of the implementation, and for detailed implementation, please scan the QR code to read our AWS blog. So we have detailed implementation in the blog together with our code samples in our AWS samples Git repo. Please to scan the QR code to get this information. All right, that's pretty much about it. And thank you for your time. I'm happy to take any questions.
Okay, thank you. Thank you, Sherry. Are there any questions in the audience, from the audience? Okay. Well, while you think for a question, I have one question for you. Can you tell us a bit of, for example, what type of data modalities do you see federated learning being used more often, at least maybe from the projects you have been involved? Do you see images being more popular, other type of data? Can you share something?
The customer that I work with on this project it's basically the tabular data set to generate regression models, classification regression models. And I've also seen some about using image data, like using the PyTorch package